In today's lesson we're going to look at two types of quantities, but first there's a couple of key words that we need to know and understand. So a quantity is anything which can either be measured or just given a value or assigned a number. You might also hear me use the term magnitude. Now magnitude is just another word for size, or it can be the number linked to a quantity. So if it was 100 degrees Celsius outside, the magnitude of that temperature would be 100. There are two main types of quantity we're going to look at today. We're going to look at vectors and scalars. Now the main difference between these two is that vectors have both a size or a magnitude and a direction associated with them, whereas scalars just have a size or a magnitude but no direction. One example of a scalar quantity is mass. Now this gentleman here, when he stood on the scales, it told him his mass was 80 kilograms. Now it doesn't matter whether he'd start moving to the left or to the right. He'd got the same amount of particles in him, so his mass would always be 80 kilograms. Direction doesn't matter, just the size. Conversely, a vector quantity has a size and a direction. So if I were to say that I were going to apply a force of 10 newtons on this box, that wouldn't tell you enough. You'd need to know whether it was 10 newtons to the right, whether it was 10 newtons down, 10 newtons to the left, or whatever direction the force may be applied in. Force is a vector quantity, so it has to have a size and a direction. Now that we've been through that theory, you should be able to answer the following progression questions. What is a quantity? What is the difference between a vector and a scalar? And you should be able to name an example of a vector and a scalar. Okay, now that we've established the difference between a vector and a scalar, I'm going to give you some more examples, specifically examples of quantities that can come in pairs. So we're going to look first at the difference between displacement and distance, and then at the difference between velocity and speed. So to explain the difference between these quantities, we're going to look at the example of a runner on a running track. If we establish that this is a 400 meter track and this is our runner here, if he were to run one full lap of the course and run back to exactly where he started, we would know instinctively that the distance he has travelled is 400 meters. Remember, distance is a scalar, so it doesn't take into account direction. He has just moved 400 meters. However, if we take into account the direction he has moved, we need to think about where he started and where he finished. Now he finished in the exact same place that he started, so his displacement from where he started is actually 0 meters. This is the difference between distance, which is a scalar, and displacement, which is a vector. Displacement is the distance you moved in a straight line from where you started in a certain direction. Next we're going to look at the difference between speed and velocity. We're going to stick with the theme of the runner on the track. Now, if our runner was to do a lap, and I were to tell you he was travelling at 4 meters every second, that would be his speed. He would have a speed of 4 meters per second, because speed is just how far you travel in a certain time. So every second he would travel 4 meters. However, if we were going to take into account velocity, that's his speed in a certain direction. So when he gets to this point on the track, his speed would be 4 meters per second, but his velocity would be 4 meters per second south. When he gets to this particular point in the track, his speed would be 4 meters per second, his velocity would be 4 meters per second east. When he gets to this point in the track, his speed would still be 4 meters per second, but his velocity will be 4 meters per second north. So remember, speed is a scalar, it's just how far you travel in a certain time, direction doesn't matter. But velocity is speed in a particular direction. When you hear the term acceleration, you have to bear in mind that acceleration is related to velocity and not just speed. So the acceleration of an object is how much its velocity is changing. Remember, velocity is a vector, so it has both size and a direction. So if either of those things were to change, then you are accelerating because your velocity is changing.